What do you think, Trista?
What do you mean?
Well, our documentary is definitely taking shape, but all our footage focuses on how the blimp is built.
Right.
So I figure maybe we should start figuring out how the blimp actually flies.
Okay, so what are you thinking?
Well, we know the blimp is filled up with helium, and anybody who's been to a birthday party knows that a balloon filled up with helium can fly.
Okay, so who should we interview about this stuff?
I don't know.
Well, let's think for a minute. Helium sounds like science, right?
Yeah, science. Chemistry, actually.
Okay, well, let's see if we can get a chemistry professor from the university.
Yeah, that's a good idea.
Well, it took you long enough.
I'm just doing what Professor Mazer told me to do.
What's in the bag?
A little something we need to digest before we go and interview him.
Huh?
Well, I called him, and he said that to understand how helium and hydrogen make things float in the air, we'll need to think about the basics of matter.
Abby, ice cream sundaes, we have to focus.
No. Check this out. When I was talking to Professor Mazer, he said that when we go up there today, we'll be talking about the structure of matter. And we've been talking about the structure of matter the last few days in class.
You got a spoon?
An easy way to understand the building blocks of matter is to compare matter to ice cream. Now, stuff like hydrogen and oxygen, these are called elements. Then there are atoms, right? You can think of atoms as scoops of ice cream. So a scoop of vanilla ice cream is like one atom of oxygen. Next are molecules. Here's the fun part. We can think of molecules as ice cream sundaes, and sundaes are made up of different scoops of ice cream. Like my sundae is made up of 2 scoops of chocolate ice cream and 1 scoop of vanilla. 2 hydrogen atoms and 1 oxygen atom. H2O, or water.
Hey, that is pretty cool.
Yeah, I'm aware of that. Today we're on a mission to find out how blimps are able to fly. Over the last century, aeronauts have used hydrogen and helium in blimps and balloons to achieve flight. But what makes hydrogen and helium so special? We're here at Kent State University in Kent, Ohio, and we're looking for the answers to these questions.
So, Professor Mazer, how are atoms structured?
Well, basically, atoms consist of 2 fundamental particles, and they occur in, depending on the element, you would have certain numbers of each. If you had hydrogen, it would just consist of a proton. All of the other elements consist of a combination of a certain number of neutrons and protons. And if we look at helium, we can see that there are 2 of these blue structures, which are neutrons, and 2 white, which are protons.
So why does the blimp float up into the air?
It's basically just a big gas bag. It's an envelope that can contain gas. And we'll put some gas molecules in here. But I want to indicate that for a unit area, there's only a certain number of them. In any given area, there's approximately the same number. In the atmospheric gases out here, we want these atmospheric gases to be about the same distance apart as these are inside. Now, these molecules out here are these big, massive oxygen and nitrogen molecules. But in a given space, there are just as many molecules of these heavy gases as there are of the helium inside. So the number of helium molecules in our artificial balloon here, because they're at the same pressure as the atmosphere, is approximately the same as these monstrous molecules outside. And these guys, 2 of these, don't weigh anywhere near what 2 of these weigh. And so this is heavier, pushes down, this is lighter, just like a bubble in water, it goes up.
Burst into flames. Oh, my, get out of the way, please. It's burning, bursting into flames. This is the worst of the worst catastrophes in the world. All the humanity and all the prayers is screaming around it.
Creepy, huh?
Yeah, that was just awful.
So, do you know why the Hindenburg burned?
Didn't it have something to do with the kind of gases they were using?
Well, now they think that it had something to do with the material used for the outer skin of the Hindenburg. There was this special protective coating put on the outside of the skin, and I guess that this protective coating was really flammable. All it took was just the tiniest static electricity spark for the whole ship to go up in flames.
Crazy.
And from what I can understand, the Hindenburg is why there aren't more ships now that use hydrogen as a lifting gas. Even if hydrogen is lighter than helium, helium is just seen to be the safest bet.
I wonder if there's any other gases that they used over the years.
We could talk to the people at the Lighter Than Air Society.
Yeah, they were really nice last time we were there, so I'll set something up.
We need to find out what kinds of different gases have been used in lighter than air vehicles. That's history, right? So we'll be talking with Mr. Joe Huber of the Lighter Than Air Society here at their museum in Akron, Ohio.
What gases have been used throughout history, and why?
Well, originally they thought that smoke was the lifting body, so they used smoke until they discovered it was really the hot air that was in the smoke that made the difference. The easiest available gas after that was city gas, which was used for homes before natural gas became common. Hydrogen, once they worked out the process of making hydrogen, which is the most common gas in the universe, provided an inexpensive and a very high lift capability. Works extremely well. Then helium was discovered. And once helium was discovered, it became the ideal gas.
In the early days, it was believed that coal smoke was what made the Montgolfier brothers' balloons go up.
Which wasn't exactly right. It was the temperature of the air in the balloons that made them fly.
We also learned that natural gas was used as a lifting gas at one time.
These days, it's basically the big three: hot air, hydrogen, and helium.
Hydrogen is the lightest gas of all, but helium is safer, and that's why helium is used in the Goodyear Blimp.